Hi everyone, this is a quick tutorial to know how to encrypt any message using RSA algorithm. First, what is RSA algorithm? It is an algorithm used for encryption, but not like the usual encryption, we use here two keys. So it is asymmetric encryption. One of the keys is public and one is private. Sometimes we first encrypt with the private, sometimes we first encrypt with the public and decrypt with the other one. So it depends on the need or the usage of the algorithm in this way. So first, we might have such problem like this one. Given P and Q, encrypt the message M, which is equal to 5. So first, we need to calculate something called N. N is equal to P times Q. P times Q. And N here in this case is equal to 3 times 11, which is 33. Okay, secondly, we need to find the decryption key. So to find the decryption key, we need to calculate something called phi of n. And phi of n is equal to p minus 1 times q minus 1. And in this case, it will be 2 times 10, which is 20. So on calculating this one, we now can calculate E. So to calculate E, E should be relatively prime to P of n, which is 20. So to choose a number relatively prime to 20, we can choose 3. So now we have our E. So now we can do the encryption, but let me add another step. We can calculate the private key or the key to decrypt. So we can calculate it such that D times E modulus P of n equal to 1. And D and E should be prime too. D should be prime, E is already prime. So to choose a number that would give me modulus phi of n equal to 1, we can choose D as 7. So D equals 7. Surely we can choose other numbers that will suit. So now we have D and E. So now to encrypt our message, we have the message M. So we get M, which is 5 to the power of E modulus n, which we calculated in the first step, which is 33. So now we can calculate this on the calculator because it's relatively small numbers. But if it is very large numbers for the calculator, we can calculate it manually using the following algorithm. So 5 is A, power 3, which is P, modulus n, which is 33, okay? So we need to find B in binary, which is 3. So 3 in binary is 1, 1. So now we have 2 bits, okay? We initialize the value with 1, or use the first value as 1. So we do the following algorithm repeatedly. So we use 1 square modulus 33, and we get the first value, which is 1. But here in this case, we have the first bit as 0, as 1, I mean. Okay, so this is index 0 and this is index 1, and we move from left to right. So we have index 1 with value 1. So since it is value 1, we do the following. We take this answer, which is, let's call it F, and multiply it by A. A in this case is 5, and take the modulus again. So this is the result of the first step. So secondly, we repeat this for the second bit, which is also 1, and it is bit 0. So F equal 5 square modulus 33. And in this case, we get 25. So for the last step, we also will multiply 25 by 5 and get modulus 33 to get our final value, which is the value of the encryption. Let me calculate it. It will be 26. So these are the steps, and to decrypt this message, we can do the inverse. We can just use 26 for decryption. We will use 26 to the power of, let me check, D was 7 actually. Yeah, so we can use D equals 7. D is for decryption. This is our decryption key. Modulus also 33. And we can apply the previous steps again. And the answer should be 5, our original message.